Asraful Islam is working with KMDA, his chief engineer in KMDA, and he has drawn very many solid waste management projects for the state of West Bengal on behalf of KMDA. Mr. Akhoy is working in the field for processing solid waste management as well as biomining. Now you all know that solid waste management rule came in the year 2000. Many ULVs actually failed to do the needful as per the rule and the direction of Ministry of Environment and Forest, Government of India, State Environment Department, etc. In 2016, Government of India again revised the solid waste management rule. This is Municipal Solid Waste Management Rule 2016. On the basis of that, we found ULVs are coming forward. But again we found that many municipal authorities were not up to the mark of taking up the proper solid waste management. As a result, Honorable National Green Tribunal intervened, and then they actually gave stress on the need for solid waste management. The ULB pleaded to National Green Tribunal that land is not available for them to process solid waste which are getting generated. You all know that as per rule, solid waste need to be processed. There is no scope for open dumping, uncontrolled open dumping. Previously, we were doing uncontrolled open dumping and thereby causing environmental pollution, air pollution, groundwater pollution, surface water pollution, etc. So therefore, the land since found to be not available to the ULBs, so Honorable National Green Tribunal then directed that ULB should take up bio-mining process. So mining is taking up with respect to minerals, etc. in the country, but this is bio-mining, is a special type of job need to be done for the old legacy waste. So KMDA as well as SUDA initiated the program of biomining in the state of West Bengal. We have 128 urban local bodies in West Bengal, and the biomining process that is includes the bioremediation also and others. So the SOP was prepared, and KMDA and SUDA entrusted very many agencies for doing the biomining. Mr. Akhoy from Eastern Organic Fertilizer, they got the opportunity to work in different places, especially at Dhapa, as well as big dump site at Pramod Nagar, as well as in other places. So therefore, he has got experience in the field. I hope in this particular session, both the speakers will highlight not only the legacy waste biomining, but also fresh waste processing. So both these aspects will be discussed elaborately, and I hope that it will be beneficial for us. I request both the speakers to present their solid waste management issues and challenges for 30 minutes, and then we will take up both the papers for elaborate discussion. I request first Engineer Asraful Islam to present his first paper.
Thank you, sir. Thank you, sir, for giving me the opportunity. Hope everybody is not feeling sleepy after good lunch. Let us start. So, my presentation will be on municipal solid waste management in developing countries, challenges which we can turn into an opportunity. So, next slide, please. First, let us uh, discuss about a little bit about municipal. What is municipal solid waste? The municipal solid waste is the portion which we left out after use and ultimately goes to dump here. And the municipal waste generation rate in our country is around 0.5 kgs per capita per day. In different developing countries, there are rate is different, starting from zero point 0.5 to 1.95 kg per capita per day. In Thailand, it is highest rate. In India, in but the rate is also changing because of lifestyle changes and more packaging we are using packaged materials we are using. So that is why the rate of generation of solid waste is increasing. Next slide. Uh, the total solid waste generation in 2023 in different states of India, coming to the Indian scenario, total waste generation I have given here. Maximum solid waste generates Maharashtra. They are generating around 22,632 TPD of solid waste every day, whereas in our state it is around 13,700 ton per day. Every day, this much huge quantity of waste is generated in 128 UL bits of our state, and it goes to dump here. Certain part is started the treatment and processing we have started in certain areas, certain municipalities, but entirely we have not yet started processing and this disposal as per MSW rules 2016. Next slide. Yes, the collection efficiency, there is another term. What we generate, that need to be collected and finally disposed of. So, till there is a gap in collection of municipal solid waste from household, from each and every household. Maximum in our country, maximum 100% achieved by Chhattisgarh. Uh, in our state, it's around 92.1% only. Kerala is least, they are 27.2. On an average, it's around 90%. Next slide. Yes, the composition of municipal solid waste. For proper disposal and handling of municipal solid waste, we need to know what are the composition of the solid waste. Here, mainly we have got two kind of solid waste. One is dry waste, another one is uh, wet waste, which is biodegradable one. And the biodegradable part of solid waste contains kitchen waste, food waste, vegetable waste, and non-vegetarian waste, uh, including garden waste. Dry part, we have paper, plastics, wood, board, chips, cardboard, metal, glass, and rags, etc. Apart from that, certain parts are inert materials also there in MSW. That is sand, pebbles, what we get from street sweepings or sweeping of the households, uh, courtyards, etc. Pebbles, grit and pebbles. Apart from that, certain construction and demolition waste is also coming into the MSW source. And apart from that, domestic hazard, certain part is domestic hazardous waste. That is sanitary napkins and bandages or all other medical kind of things which we use at households. Next. Next. Yes. South Asia, East Asian countries, there is a pie chart. Most of the, more than 50% is biodegradable waste, and metal is 3%, glass around 4%, paper and cardboard contains 10%, rubber, leather, etc. it's around 2%, plastic contains around 8 to 10%, which is a big amount, and it can be recycled and used for the used as a raw materials for the plastic industries. Next. Yeah. Now we have to manage all those which are left out in households. We have to manage it. So how do we manage it? We need to have proper planning, engineering, administration, and financial and legal aspects, so that we can manage properly municipal solid waste. Why do we manage this solid waste? To protect the health of public, to provide proper sanitation to the community, and it is the responsibility as per Indian Act, it is the responsibility of ULB. Next. Yes. The solid waste management hierarchy. Here, first we should try to prevent the waste coming into the source. Then we can try to minimize it or reduce the solid waste. Like how to reduce it? We can use bags instead of plastic one, cotton bags, jute bags for marketing or other purpose. But we do not do it. We take the single-use plastic bag and put it in dustbin. That we should not do, so that we can minimize our waste. Reuse it. The materials which we get and throw it out, we should not do that. We can try to reuse it so that waste can be minimized at source. Now coming to the recycling, what part we can recycle? Many metal part, glass part we discard and throw it out with the garbage that goes to dumping ground. All those are valuable items. Apart from that, we also throw out plastic bottles, plastic bags. All those things can be reused, can be recycled. Here it is practiced, but that is informal sector. Informal sector takes care of it. Usually they pick up the water bottles and all other things, rag pickers. They take it, and there are certain few dealers, those who collect these recyclable bottles, and they gives it to the industry. They prepare the plastic bits and further reuse for making plastic items. And those plastics and other combustible materials which are not usable or recyclable, with that we can recover, we can produce energy by it can be done through combustion. Apart from that combustion, biomethanation is also we can practice. The biomethanation can be done from the organic solid waste. And the least preferred option is disposal. Disposal is obviously the inert part and the residual part from all these activities will go to landfill site. Next. Yes. What changes we face in solid waste management in developing countries, particularly in our country? That is source segregation and collection from households. Source segregation is very important part in solid waste management activities. Source segregation means each and every household, the dry waste and wet waste shall be separately kept in a container and disposed of while the municipal people comes to collect the waste from household. That is very difficult task. For this, huge IEC activities need to be done. Still in West Bengal, most of the municipalities are unable to get the segregated solid waste from the households. In Kolkata also there are certain wards they have tried, and in other municipality also partially we have started, full we have not yet reached. Next, not next slide, previous slide. Yes. Availability of sufficient land for MSW. As sir said, the municipality do not have sufficient land for setting up MSW processing plant. That is why the biomining of legacy waste comes into picture, and KMDA, SHUDA and Kolkata Corporation has started biomining of legacy waste so that the land can be reclaimed and the same land can be used for setting up processing plant. Till date, the Kolkata Metropolitan Development Authority has biomined around 30 lakh metric ton of legacy waste. Simultaneously, Kolkata Municipal Corporation is also doing, they have also done a large quantity of biomining of legacy waste. SHUDA also taken up certain work of legacy waste that they have done around, I hope, 20 lakh metric ton. Then coming to the quantity of legacy waste, the population growth of the urban population growth is quite high. It's exponentially growth taking place in urban area. In 1971, the urban population was around 20% of the total population, whereas as per 2011 census, it is 31% of the total population, which is going to be around 40% by the year 2040. At present, it is around 36% of the total population. This huge population, with the huge population, the huge growth of the huge generation of this municipal solid waste is a big challenge for the engineers practicing in urban area, or this huge, apart from that, composition is also changing rapidly. Earlier days in 70s, there was no plastic waste in municipal solid waste. Whereas nowadays, plastic is a big problem for the municipal solid waste. The single-use plastic is really a challenge for the engineers to how to tackle it, how to take care of, how to dispose it of. Single-use plastic is not usable even after certain processes. Then increasing severity of adverse impact with open dumping and all the open dumping, open burning causes environmental pollution, like open burning causes air pollution, open dumping causes water pollution, uh, other soil pollution, etc. To take care of those environmental degradation, it's a big challenge for the environmental engineer or civic body. Limited policy frameworks. National level and state level policy is there, but implementation of the policy with time-bound manner that needs to be enforced in local level as well as national level. Lack of political priority. What happens? Most of the our political bosses, for them, the solid waste management is not that much priority like water supply. So, as it is not a priority, it goes back and gets less fund. That is why it is very difficult for the civic body to take care of municipal solid waste management properly. Resource generation. As plastic, glass materials, and metals, a big part of the solid waste, all those are practically a resource for certain industries. So segregation, and by segregating all those things at source, we can generate resource out of it. Acceptance of targeted technology. Yes, that for processing and disposal, there are a number of technologies available in the market. Which one need to be selected? Most of the technologies has come from developed countries. That all those technologies may not be suitable for our developing country or for our country. Local level, particular technology which will be best suited for that area need to be looked after. For that, a pilot project may be taken up whether this particular technology is suitable for that area or not. Increasing cost of waste management. As in earlier date, what happens? Most of the solid waste used to dump in a dumping ground or low-lying area. So cost of treatment and disposal was nil. Nowadays, as per mandate of 2000 MSW rules 2016, processing and disposal is must. So that increase the cost of waste management as a whole. So fund flow to the waste management is very essential at present. Next. Yes, the source segregation I already discussed. Availability of sufficient land. Here another problem. Everybody do not want to have a solid waste management infrastructure besides their home, not in my backyard. This income prevents city and policymakers to allot suitable land for development of solid waste infrastructure. Next. Yeah, this slide also I have discussed. Next. there is also a realization that waste management could be supportive for the other issues, like what happens if solid waste management is not done properly. They will throw it out in the nearby drains or khals. As a result, it gets choked and ultimately gets waterlogged of that particular area. So if we manage the solid waste properly, that open dumping or throwing the waste into the stream or channel will not be there, and we can get rid of the waterlogging problem there in the municipality. Next. Yeah. Resource generation, as I told that all the metals, plastics, glass, etc. can be a resource for the industry, and as a result, what will happen, the resource required for the natural resource we use in the industry, that quantity will get less, and resource generation, the energy required for resource generation from the natural source will also be also reduced. Next. I have discussed already this technology, acceptance of targeted technology. Next slide. Next. Yes. Now coming to the opportunities in municipal solid waste management in developing countries. What are the opportunities are there? The solid waste management is having a huge market. In India, it is around 1 lakh crore in this year, and it will reaches around 1.4 lakh crore within a 5 year. Next to 2029, it will reach around 1.4 to 1.5 lakh crore with average CGR or CAGR of 6. Cumulative average growth rate of 6.1%. And circular economy is gaining a popularity. So we can reuse of resource and recycle of the resource. We can have a circular economy in practice. Collection transportation is also having a huge demand, where the private partner also come in to the picture. Numerous startups are introducing innovative solutions for disposal, collection and transportation, real-time monitoring. Many startups are coming up. All those innovative ideas we can take up as an opportunity for solid waste management practice. Next. The market growth. See the market growth. It's a huge exponential growth will be taking place within a 5-year time period. Next. Yes. How we can use MSW is an opportunity. The biodegradable portion we can convert to convert the biodegradable part of waste as compost, biofertilizer, and biomethanation, anaerobic digestion. Finally, we may get biogas, CBG, compressed biogas, which can be used as a thermal energy, like we can use as a fuel for cooking or automotive fuel, or else we can use it in a generator and we can generate power from the biodegradable part of solid waste from CBG. Apart from that, we have a combustible part of municipal solid waste that we can use for power generation, like waste to energy plant, by incineration. Also, through incineration, we can generate steam. The steam, many industries are there those who use steam, that steam, they use coal or fossil fuel for generation of steam. That we can, the combustible part of solid waste, we can use for the steam generation, and that steam can be used in nearby industries, and thereby we can reduce the use of fossil fuel. And yes, C&D waste is also a part of municipal solid waste, which can be recycled and used as an alternative building materials, or paper blocks, tiles for footpath, etc. We can manufacture from C&D waste. And inner part anyway ultimately will go to landfill. Next. Next. Converted energy contain different types of waste into various forms of valuable energy. Energy production from energy not only helps meeting the increasing demand of energy, but also it will reduce municipal dump site. As you have a huge scarcity of land, so requirement of land for the landfill site will also get reduced if we use MSW as a source of energy. Also, we can co-process the combustible part of municipal solid waste in cement industry. At present, cement industry takes around 5% of the municipal solid waste with their as a fuel for their boiler. As a fuel for their kiln, the cement for manufacturing cement. Apart from that, we can prepare RDF, refuse dry fuel from the plastics and other combustible materials by shredding, cleaning, etc. The calorific value of RDF will be more than 1500 kcal per kg, kilocalorie per kg. Next. This is a flow diagram for waste to energy plant for using dry waste as a fuel. There will be a combustion chamber where directly the dry waste may be put with air supply will be there, and steam with that heat, steam boiler will run and steam generation will take place. With that steam, it will go to the steam turbine and generates electricity, and the flue gas which will be coming out from the boiler need to be purified before leaving it to the atmosphere. And the bottom ash coming from the combustion chamber may be used as a for manufacturing bricks, or alternatively it can be disposed of in landfill sites. Next. It is also a cross section for a waste to energy plant. The waste is put here, and it puts this into the hopper, directly goes to the chamber, and with that steam it generates electricity. Next. Yes, waste to energy through biomethanation. We have around 50% of the biodegradable waste, which is that is coming from kitchen waste, vegetable waste, food waste, etc. Those are biodegradable part, and with anaerobic digestion of this biodegradable part of solid waste can produce huge quantity of methane, which after purification it gets if we compress it and use it as a CBG, it is having a high calorific value and gives it can be used as a resource. Biomethanation is one of the most technically viable options for municipal solid waste for the developing countries due to presence of high organics and moisture content. The CBG can be used as a generator, as a fuel for generation of electricity. CBG can be used for renewable automotive fuel or cooking gas, etc. Next. Yes. This is a flow diagram. Little bit pre-treatment is required, means shredding and mixing with water. Then it goes to digester, where anaerobic decomposition takes place and produces biogas. And the slurry coming out from the anaerobic digester also gets processed, which with that sludge we can prepare good quality manure. Here 25 kg of NSW, or let's say 100 kg of biodegradable NSW can produce 4 kg of CBG. That means in India, if daily generation is 1,60,000 TPD of waste, from which we can have 3,200 TPD CBG, compressed biogas, which is biogas production is having a huge potential, so that we can use it as a potential source for energy. Next, combustion and steam generation. The dry part, which at present we discard it in dumping ground, that can be used as a fuel, and we can generate steam out of it, which is used for the industry. Next. Refuse drive fuel already I have discussed. Next. Yes, this is the flow chart for generation of refuse drive fuel. Raw garbage, it comes, and then pre-segregation need to be done. Primary shredding is done. Hot ware is passed through the shredded waste so that it gets dried up. Then secondary shredding is done further, and after that air classifiers and it blenders and certain additives are used to blend it, so that pelletization takes place and finally stored and used as a refuse drive fuel, where we can use RDF in co-processing, cement kilns, co-combustion in coal-fired power plants, on-site or off-site, appropriately designed waste incinerator for thermal recovery and power generation. Next. Source of recycling. We have around 8 to 10% of plastics in our waste. Apart from that, the plastic, we have metals, glass, in municipal solid waste. These plastic and metals and glass part, we can recycle it. The plastic which we get in waste, that can be used as a resource that can be used for making plastic granules, which is further used for making plastic chairs, uh, plastic furnitures, and many other plastic items. Apart from that, the recycling is helpful for helpful in providing raw materials for the industry. Next. Plastic waste in road construction. Uh, Ministry of Road Transport has laid down certain criteria for use of plastic in road construction. As per IRC 98, around 6 to 8% of the 6 to 8% waste we can use with bitumen, so that requirement of bitumen gets reduced and cost of road construction is also gets reduced. Next. Yes, there is a huge opportunity in employment generation in solid waste management. Collection, it's a labor and manpower oriented. Primary collection of municipal solid waste is highly manpower intensive activities. So huge employment generation can be there, though it is at very lower level, but that employment generation will be there. Apart from that, the processing and disposal also requires a huge labor, manpower and skilled manpower also. There a huge opportunity for employment generation. Next. Land restoration, soil health improvement, and plant nutrition. As I told, the biodegradable part of solid waste can be used for manufacturing compost. That is a organic manure which can be used as a organic fertilizer or soil enricher. The NPK value which improves nutrient profile, aeration, porosity, structure, moisture content of the land, and nutrient holding capacity of the land. Next. Thank you.
Thank you very much, Asraful, for your excellent presentation. We'll take up the question later on after this presentation. Okay. I now
Thank you, sir.
request Mr. Okhoi to present his experience working with waste management.
Very good afternoon. I'm Akshay Satnaliwala. I represent Eastern Organic Fertilizer. Thank you to IPHE for inviting me, and thank you for everyone for your attention. Today I'll be presenting about the challenges and issues faced in solid waste management. As a company, we've been in this field for more than 20 years, started by my father, and now I am taking up this role as a director of this company. If you can have the presentation. Yeah. So, next slide, please. So, just a little brief about us. We started in the year 2000. Our first project was in the fresh municipal solid waste at Thapa with the KMC, and the plant continues to run there. Overall, after that, we have also worked with SUDA and KMD under the Urban Development and Municipal Affairs Department. We have started, very recently, we have started the biomining also at Bedebati, and the fresh waste processing units have also just been in the process of starting at all the various ULBs in the Hooghly district, such as Chabdani, Bedebati, Konnagar, and also recently we have just started the fresh waste management at Siliguri Municipal Corporation. So I'm very thankful to all the government departments, mostly West Bengal Pollution Board, Control Board, KMC, PMC. We've just finished the biomining project last year at Mullaghpedi. We finished that project and the land has been handed over back to the BMC. And this is our experience, and I will take more into the issues and challenges. So next slide, please. So an article in Times of India mentioned what is the future of solid waste management, how it is growing, what are the ways in which companies, startups, innovators are looking at it, at this problem. So we believe the future of the circular economy, and this is my personal belief also, is that it's all going to depend on how much we can recover. The material resource recovery all depends on that, the technology on which we process this waste, and we can recover this waste and we can channelize the waste to put to its use or the application. If we can reduce the waste which is going to the landfill, then the resource recovery percentage is higher, and thereby the overall economy, the circular economy, is more progressive. So this is my father, he's the managing director of a company, and this is what we believe, and this was published in Times of India last year. Next slide, please. This is a very important slide. Whenever I am asked about solid waste management, I always talk about what is the circular loop of solid waste management. We have to understand that the first is the generation of the household solid waste. It can be at our houses, it can be at our workplace, an institution, anywhere. The generation is the start of the waste management. Thereby, the waste is traveling via primary and secondary collection through the ULB, where door-to-door collection is taking place, and from there the fundamental part then becomes the segregation of waste into dry, wet waste, and the other different kinds of wastes that are there. In West Bengal, over the last few years, the quality of segregation has improved and increased, though we are not at 100%, but we have definitely improved, because there is a general thrust that we need to do more and more quality segregation. So the ULBs have tried to capacity build their segregation, and there are more challenges, we'll come to that, but primarily as we see, the segregation of waste is where from collection, from the primary door-to-door collection and then putting to a secondary collection point. Some of you might have seen there are certain KMC compactor stations, which is a secondary collection point all over the city. Similarly, there are other secondary collection points in different municipalities. So that is also very important, because there we need to ensure that the segregated material does not get mixed. So after that, when this waste is again traveling via the transportation through either dumpers or compactors, they are not mixed. So again, when the processing unit is receiving this waste, it is coming in the form of wet waste and different in terms of dry waste, or any other waste if it's biomedical waste or CNT waste. The first generation of household waste, primary collection, secondary collection, and then transportation is generally taken up by the our local body or the municipality. Processing is like for us, for private players or companies who are in this field or have the technical expertise. So, which is where we come into play, and then we try to process this waste, whatever incoming fresh municipal solid waste, or for the matter if we are looking at legacy waste biomining activities. What are the applications of these recovered fractions? They can be either The recovered fraction can be put to use as a soil enricher or a compost. If I'm talking of fresh waste, it can be sold as compost as per the FCO norms, which is under 4 mm. If we look at the combustible fraction, which Ashraful sir mentioned, which can be put to use into RDF, which cement industries are taking into consideration. If we are looking at plastic and other metal and glass, we are looking at material recovery facilities, which can take up this material as a resource and then recycle, upcycle, and then again put it back to the circular economy chain. Then we are moving to the disposal. Now, the challenge is, even though we have this resource and material, it is very important that we can utilize this material to a different particular industry, whether it is an automotive industry in terms of bio-CBG, or if you're talking about RDF to a cement industry or a waste to energy plant, any utility and disposal. So, as I mentioned, it is very important that once we have this material resource ready, after processing and recycling, it is also important that we can send it to the right industry or the right company which is buying or procuring this material and then disposing this material, so that this material is not going back to landfill. When we are completing this entire circular loop, then we have a clean city mechanism in play. So as I mentioned, the entire loop is complete when collection, segregation, processing and utility is done in a seamless manner, where there are various number of stakeholders, including the government departments, the policymakers, the municipalities, or the urban local bodies and private players and agencies, waste management agencies like us, recyclers, when all of them come together having the same mission to make the city clean, then this entire circular loop becomes successful. So far, we have got Indore as a example which is doing really well. There in the country which have done well. As far as our state is concerned, some mentioned 30,709 metric ton per day is getting generated as per the WBPCB report in 2020-21, which is growing at 5% year on year. So you can expect, since the population explosion is happening, more urbanization is happening, people in rural areas are moving and they are shifting to more larger cities, you can expect this waste to go further. We are right now 1.4 billion, as sir mentioned, Ashraful sir 0.5 kg to 1.9. So similarly, the capital consumption is increasing, so we can expect that the waste will only grow. So we, as a total, for this circular economy to be successful, there are various challenges, and we'll take up one challenge after the other. The sir has already mentioned, but I'll give you a more practical example in terms of what happens behind the scenes as an agency. So for this to really take place, there need to be more and more emphasis on recycling as well as managing the solid waste. Next slide. Just want to give you some data which we tried to collect the last few months at our different sites. And what we feel is that, sir mentioned 57% in the developed economy somewhere biodegradable and organic. At our sites, mostly 49-50% is what we are getting as wet and organic. When we talk about plastic waste, it's about 8 to 10%. We sum it up with dry waste, where we have some cloth, we have some rubber, we have other dry waste particles. It can lead up to about 24 to 26%. We're looking at glass and metal close to about 2 to 3%. There is the presence of the informal sector, which is also taking up this waste before we can actually data that we've got. And then we've got paper bags, and other forms of biodegradable, which is about 5%. So the entire 57% which sells close to about 54-55%. Then we are looking at some inert and CND material, which is close to about 8 to 10%. It may vary to 2 to another 2%. And a little talking about, let's say for example, KMC. So there is the presence of some e-waste as well, which again is taken up by the informal sector and through various channels. it is reaching to the recyclers. So in a nutshell, this is the different kinds of waste that we are receiving at our different units. Uh, as I pointed out, the fundamental challenge that lies for us at this point is collection and segregation. If collection and segregation is improving, definitely the application also improves, because then there is a material resource. Next slide, please. A little about biomining. So I mentioned that we should throw a little bit of emphasis on biomining. So if I talk about biomining and bioremediation, as per the foremost is, before we do the screening or the recycling bit, we have to stabilize the waste. What we do generally at our sites is the formation of windrows. We make small heaps of waste, with this waste is stabilized before screening. Now, why do we have to stabilize this waste? If we are not able to stabilize the waste, then any mechanical separation, whether it's through a ballistic separation or a power screen or a trommel, which are the machines which are used for screening this waste, there will be more moisture. When the moisture is very high, then what happens? All the wire meshes, all the conveyor belts that are used to screen this waste will get jammed. They will not be able to function properly, and hence the desired quantity and the capacity of processing will get defunctional. It will not function as per the requirement, and we will not be at target to process this waste. So it is very important to stabilize the waste and then screen this waste. And as per the SWM rules, we are supposed to ensure that we are able to get 4 to 5 different components. Mainly, generally, what we look at 25 mm above this material is based on the dry part, which is this RDF is basically going waste to energy or cement plant, which is utilizing it in the cane as earlier. Generally, 35 to 16 or 16 to 4 is the form of mixed earth, or we call it, this is basically material which is not soil friendly, but this can be utilized for some sort of land filling, or it might be further shredded in the form of, if there's any plastic, smaller plastic, it can be utilized for various forms of recycling, shredding, and again it can be put back to use. The material which is below 4 mm is basically your bio earth or good earth. If the carbon content is very good, then we can go for compost making. Otherwise, this can be used as for basically a filling material as a soil conditioner. But we have to make sure that the lab tests are good for it to be taken up in the market in that direction. Generally, the idea of a biomining is because of 2 or 3 reasons. We'll just take it up in the next slide. So, while we are processing the biomine waste, the key aspects for implementation is the space management. As sir rightly mentioned, Anurag sir mentioned, as well as Ashwin sir, space is a big issue. It is also very, very restricted when we are looking at any kind of dump site. Old legacy wastes are there, some lakh tons are there, hardly any space is there to work. So this is a very big challenge for us when we are looking at biomining. The second is how we manage the leachate, and the third is fire control and safety. As you would see in different dump sites all across India, maybe at night or maybe during the day, when there is some sort of fire or there is odor which needs to be managed, which cannot get managed properly. So these are the different challenges we face as an organization when we are dealing with biomining at different sites. Please, next slide. So when we are looking at space management, this is one of the most critical aspects for us to solve. And when we are looking at biomining, we have to see which area we can identify through drone survey, different kinds of surveys, where we can identify a place where we can start the biomining activity, which is the excavation part. before processing, we have to excavate. We have to also see that the waste which is on top of the top layer does not come down, because that might lead to injury, risk, loss of manpower. So we need to identify which are the places where we can streamline these activities and ensure there is enough road connectivity to easily excavate the waste. How we can move the earth movers. We have to do the different kinds of constructional activities at site, where we can set up the machinery, set up our vehicles, set up our parameters such as real-time monitoring, CCTV monitoring, so that the authorities and the departments can track how much waste is being processed on a day-to-day basis. Once we start recovering the land, then we mark those lands for the processing and setting up of the fresh waste unit, which is happening at different ULBs at this point. As Ashokul sir mentioned, that 30 lakh metric tons have been processed by KMDA, 20 lakh tons by SUDA, and another 15 to 20 lakh tons by KMC. So collectively, in the last 2 to 3 years, you can 70 lakh, close to 65 to 70 lakh tons have been processed, disposed, and an equal amount of land has been recovered. This land, 3 years back we talked, this land was valuable piece of land was lying within heaps and heaps of garbage and waste material, which has been recovered, and slowly we are moving in the direction where maybe in the next 3 to 4 years we will have fully reclaimed lands where we can process fresh waste only, so that incoming daily waste can be processed. Can you move to the next slide, please? Another very important aspect is the environmental safeguard activities. These are challenges that we face. I talked about odor control. It's very difficult now if we have semi-skilled or unskilled manpower, how we can make sure that they are able to work. There are certain enzymes, there are certain, sir had mentioned to us sometime that we can use lime powder, we can mix it and we can reduce the odor percentage, the odor control, how we can do it. Little bit more efficient practices can be taken up, but generally overall, how we can mitigate with these problems is something very important to us. And something that we also have to look at is air monitoring. If the pollution level is very high, it's very difficult for us to arrange manpower, us to ensure that the air is ambient for people to work. So generally what we do is we set up some sort of devices, or we ask the third party agency to come and monitor the air. So maybe it's 3 months or 2 months what the air quality was, and right now what the air quality is, so that it gives us a clear indication that the work that we are doing is playing a significant role in the area, and also allowing us to make the air around us better and more as per AQI levels, to reduce it so that it's more better for human beings to work there. One more very important aspect is also noise management. Now, when I talk about noise management, consider a dump site and there are people living around, and we are using these heavy earth movers, excavators. There is a sense of vibration. You might feel there's a small or a very, an area which needs to mitigate the noise management. So at that point in time, we have to see the timings at which we work, the hours at which we work. So we cannot go beyond a certain stipulated time, because then the people residing nearby, they cannot sleep, or they might be having issues with the noise. So this is also an environment management plan that we have to take care. So generally our sites, if they have to work, we have to start at around 7 o'clock in the morning, and in 2 shifts, we are maybe probably from 7 or maybe 6 o'clock to 2 o'clock, and then 2 o'clock to maybe 10 o'clock. And that at that point in time, we have to stop working, because we have to ensure that the people residing around us are not facing any kind of challenge. Next slide, please. Overall challenges, if I have to talk about in the state of West Bengal, as I mentioned, 13,709 tons are being produced. However, only 30 to 35% at this point in time is getting processed. 100% door-to-door collection is still not happening in our state. So I mentioned 92% is what we're doing. I think it is getting better, but the challenge is how many Nirmal Sathis and Nirmal Bandhus who are working on the field are being skilled and whether they are 100% efficient. Since it is very manpower intensive, as I mentioned, and even I would like to reiterate that for us to make it 100% door-to-door collection work, we need to have the necessary infrastructure, we need to mobilize and train our manpower at the ULBs and also avoid the the political or the local unrest or the agitation. Sometimes that happens because there is no accessibility or terrain accessibility to collect that waste. So those are the challenges which the ULB faces. I've just pointed that out just to ensure that you have a more clearer picture. Secondary collection points in KMC, it is still very much upgraded, but at different ULBs in different places within the 128 municipalities, it is still not yet 100% proper. Yes, there are steps that are being taken to ensure that these collection points are now equipped and better managed. Compactor stations are being set up. More efficient ways of collection is taking place. And definitely there is a stopgap, but we are moving in that direction. The one more major challenge which we face and even some of our other companies that are there in the similar field face is that they are not able to get the adequate land to make the processing unit. As such, certain units are non-operational if they are made earlier by the ULB itself or they are underutilized. For example, we need to set up a processing unit of 100 tons, but the space is only there to make it for 50 tons. So the underutility of the processing unit remains. And sometimes there is the load to process is very high and the capacity at which the plant can run just cannot fulfill. Even if the space is there, everything is there, but somehow the private player is just not able to process that much amount of waste due to its own over capacity. For example, if we can only do 300 tons per day, even though the plant is for 500 tons, if we are not financially that much accessible to our, we are not financially strong to take up 500 tons per day. So there is an overcapacity burden which is there. So for that, it is difficult at times for the ULB also to ensure that the ideal situation is reached. This is something which is an experience, so I am sharing with you. One more thing that are there, since the quantum of waste is very high, the qualified technical companies that are there to process this waste are very few. Consider 13,709 tons that need to be processed. We will need to have at least 30 or 40 companies or maybe 100 companies to actually process this quantum of waste on a day-to-day basis. And that is another challenge. Right now, maybe we have 15 to 20 good companies in this sector in our state who are working on this field and actually processing this waste. So there is something which is a challenge and that needs to, there are more and more companies that are coming in, more and more solutions that are coming in, but that is definitely a very big challenge. Even after processing, many companies are failing to have forward market linkages or agreements. For example, I have RDF there at one of my sites, 500 tons, 1000 tons, but I don't have an agreement with the cement plant because the cement plant is getting material from different other states. So what is happening is that I have to dispose this waste at a very high negative charge. And then the financial viability and modalities of working and processing become difficult. So it is very important for a company or any other agency that is in the field of solid waste management have strong relationships with the players who will utilize the material that is being processed. One very important factor for our state is the absence of very big players. If I talk about other states, there are big players like Antony Waste is there, Ramkey is there. Ramkey is obviously set up a C&D unit here. The absence of very big players, what happens there is they have the financial power to process a lot of waste and then utilize that waste. it is not necessary that they have to take up the entire thing, but what happens is when a big player comes in, there are more ancillary units, recycled companies that come together. If I talk about Ahmedabad or I talk about Rajasthan or even northwestern Delhi side, there are so many companies that are there who are taking up the plastic recycling or they are taking up the other forms of recycling because there is healthy competition, and what it does is it just creates an innovation landscape for waste management. So something when a big player comes, then the funds start coming in, and then automatically the waste management practices get better, and the entire ecosystem is benefited from that kind of a thing. One more major hurdle that we have faced in our existence is logistics. We have the product, we have the agreement, how to send this product. It is not possible that we will get trucks at our disposal to take this material from point X to point Y. So at that point in time, how we can innovate, how we can send bulk waste, let's say with the help of Eastern Railways or with the Railway Ministry, so that the cost becomes cheaper. It is more lesser carbon footprint is there because if we are sending material, let's say 500 kilometers away, there is some not less than 250 to 300 liters of diesel that is being burned just one way. But if we send this bulk material via rail, then it's cheaper, it's run by electricity, it's greener, and we can also you send the waste in bulk quantities rather than small consignments of 25 ton or 30 ton or maybe 35 ton. Next slide, please. So now we've talked a lot about the problems. What are the ways, solutions in which our company is playing a role in ensuring that we are able to utilize these recovered fractions and send it via proper channels. We are having our own city compost, which is an organic fertilizer, which we are processing out of fresh waste at KMC, at Dhapa under KMC. These are the different other companies. Indorama is there, Kripco is there, Coromandel is there. They are taking up and selling city compost in a big way in India. They are the major players. Our brand is a very small brand, and they are doing in lakhs and lakhs of tons. And they are buying this material from different units in UP, in Bihar, in Jamshedpur, in Jharkhand, down in South, in Coimbatore, in Chennai. So this is a huge market, the organic fertilizer market or the city compost market. And if we are able to make more and more city compost in the truest sense, if we are able to recover these fractions in the truest sense, then future of this business, rather this fraction remains very high. Next slide, please. There's some issue with the slide, but I'll just explain it to you. In my personal experience, I believe achieving circular loop in the plastic waste recycling is very important in the next decade or so to come. And when I talk about plastic waste, I have a little emphasis on dry waste as well, but I'll just stick to plastic for the time being. As I mentioned, the waste segregation is very important when it comes to dry waste. Moving to the logistics, how we transport this dry waste to the processing unit where the recycling can take place. We can have different applications, different products. Sir just mentioned, Asaful sir, benches and table furniture. There are also, if you will go to Spencer's or you go to any big supermarket, all the fruits and vegetables that are kept in these carts, that is made out of recycled plastic. Even the KKR jersey that they are wearing is made out of recycled plastic. They are all made out of these polymers that are recycled, and it is done through the process which sir has already technically established and mentioned to you in the earlier presentation. The material that cannot be recycled can be utilized for the waste to road construction as per the latest Indian National Congress, as per the Ministry of Road Transport and Shipping. they have mentioned that they would like to utilize this plastic waste for road. Many of the highways have come with the mixture of bitumen and plastic waste, which has allowed the construction of highways with the use of plastic, and it has reduced the cost of the overall cost of road making. The material which cannot go into road making, the last result or the last source is by way of a cement kiln, where we are utilizing this plastic waste and incinerating it as a combustible fraction to generate power and energy in cement plants. Another form, it can be with pyrolysis. With pyrolysis, oil can come into play, but that is not very viable because financially, to set up a pyrolysis plant is very high. So the end-to-use disposal for these fractions, which are taken up by these big companies like Shree Cement, Dalmia Cement, Adani Cement, which is ACC Cement, and other players who are taking up this material all over India. Next slide, please. So, one major hurdle that I was talking to you about is the transportation or the logistics of this compost or the NAFR, which is the alternative fuel resources, which can be talked about RTF. When I'm talking about transportation, I'm talking about this finished good transportation, which is going from, let's say, a processing unit to the seller. This is a huge cost that needs to be borne here. How we can be innovative and how we can reduce the cost of transportation is very important. We have utilized the railways as a good network, which has been 30 to 40% overall cheaper to us, and it also been a greener source of transportation. And we have tried to implement it for all our fractions, whether it is for the compost as well as for the RDF, and we have done it successfully. There are certain bottlenecks in policy matters that we have discussed with the ministry, and we have tried to establish some kind of communication to make this segment the most cheapest in the category when we are transporting this material. Next slide, please. In a recent interaction with the railway minister, I myself presented that how we can reduce the transportation cost and send this waste material in bulk form out of the material which is recovered via this letter. I had met him in a flight and I asked him and I requested him, and so on and so forth. In the last 1.5 months, we have had several discussions with the GM of Eastern Railways, Mr. Milan Dev Sarkar, who has been very positive that we can come up with a policy which will allow the transportation of any kind of waste related fraction to be given the most preference, priority placement of rate, as well as reduced cost. So I'm very hopeful that through our channel and with the help of all the departments, including West Bengal Pollution Control Board, KMC, KMDA, SUDA, and UD, we can make this happen. Next slide, please. So I just believe that the waste is a form of a wealth. If we are able to channelize this waste and recycle to its fullest potential, our country and state can be a very progressive circular economy, and we take it up as our responsibility that we can make this happen. Thank you for your patient listening. Thank you.
Thank you very much, Akhay, for your nice presentation. Asraful, will you please come? Now these two papers are open for discussion. If you have any question, you can raise.
Just one thing, I have just now been told that the forecast is by 6:30, a very heavy thunderstorm is likely to come here, and it's going to continue up to 11:30. So we would like to end our complete session by 6. Okay? Yes. Just people just told me that there is a podcast news released just now, which he conveyed to me just now. So we would complete our whole session by 6.
My first question is targeted to both of you, sir. One is the composition of the waste. That, there is a pie chart by Mr. Akshay showing broadly the categories, but then I feel that there are some smaller amounts but which require extensive and high technology and very much care, which are present in the construction and demolition material also for you, sir. These are, say, toxic chemicals in buildings, volatile matters, the paints, the aerosol, then explosives like the door closer cylinders which you place before segregation into any burner will explode. So there are explosives also which burst. Then there are joining chemicals. Then there are linings. There are foams, styrofoams, and many such aerosol also. So all these are, I do not know how they are segregated or how are you doing them. So this is what the first thing is, that even the medical waste within the house or hospital waste, if you take them for incineration, then that will require extensive control. The height of the chimney, the gas that is evolved, the toxic gas, and even the ash that remains, how to deposit them. Then the second part is the biomining, where legacy mining, you are taking out, segregating, and then distributing. I don't know, when they are sent to processing center after segregation, finally some of them again lands up to landfilling. Means you are taking out from the old legacy and then some goes back to the landfilling. How is this thing addressed? So waste to energy has problem. Similarly, from those unsegregated materials. And the safety, hygiene and health of the workmen working in the your legacy mining aspect, that also is very, very important. These are the points. Thank you.
Sir, you have rightly pointed out that certain materials will be there. That is there in C&D waste, right? C&D waste is used only for or as an alternative building materials. So that will not go to any waste channel where it is going for incineration. So explosion, possibilities of explosion is not there at all. And for alternative building materials like paper block and all, even if there is paint and other things, it will not affect much.
So as you rightly mentioned about just want to first take up the biomining part. So there will be certain fraction which will go to a sanitary landfill, which is there, let's say at Bejawati, where certain portion, certain percentage of inert will go to landfill, which cannot be 100% recycled. So as some part which you are saying after processing, some fraction is going as RDF to the cement industry, some is going as Gouda for filling material. For example, so there is a construction of a warehouse or a low-lying filling area which is being taken up by a company which is building, they are doing. And secondly, the material which is below 4 mm, if the carbon is to nitrogen ratio is maintained as SPO, only then and only then it can be used as a soil enricher. But maximum part, sir, the target is to reclaim the land. Now what has happened, sir? There's so much material, lakhs of tons material is there. And there is a stipulated time in which we have to ensure that the land is reclaimed and given it back for processing of fresh waste. Otherwise, this vicious cycle will not end. So what happens, sir? 80 to 90% is completely taken up, put to use and disposed in the proper channel as per the requirement of the project, and the less 8 to 10% is going back to the landfill, which is cannot be further recycled or non-recyclable. Another part, sir, which you mentioned, I think about the safety of the workmen. Yes, sir. We have to ensure that 100% our people are taken up. So last 20 years we have been working, let's say at APA also, we have ensured that the safety of our workmen is that we provide them proper place to live, proper water, drinking water, everything we ensure before taking up a site. And we try our level best, sir, to ensure that and no kind of any kind of medical problem is not witnessed, and we monitor, we do some health checkups also. So you will be very happy to know that during the first wave and the second wave of COVID, not a single case was reported in any of our sites because we created a bio bubble. We provided them with the masks. Maybe some sort of very minor fever or some symptoms were there, but no very extensive case of COVID was reported, which was something we were very proud of. So this is something that I would answer to your query apart from what sir has mentioned. Thank you, sir.
If you think I want to add here regarding your question, first of all, as per our guideline, there are rules. Biomedical waste management rule is there, and accordingly, the biomedical waste is taken care by separate way. There are agencies for management of biomedical waste. These agencies are collecting biomedical waste from hospital, government hospital, private hospital, and nursing homes. These private agencies are recognized by State Pollution Control Board. They were given consent to establishment as well as consent to operate. They have definitely incinerated and other treatment system for different types of biomedical waste, like your sharp needles, etc. Then operational theatre, that is body parts, etc. So there are separate types of biomedical waste, and accordingly these agencies are collecting and they are paid on the basis of per bed per day. Maybe say 8 rupees or 10 rupees per bed per day. The rates are fixed by the government. Accordingly, they collect and take these waste separately. So these type of waste should not come with respect to the municipal waste. But maybe we do admit if any patient is there in some people's house, my respective residential house, if home treatment is there could be chance of that getting into it. But there is a guideline by the State Pollution Control Board from COVID that any waste generated at household level must be given to the municipal collector, who will put it to the hospital separately so that the agencies could collect. So there is a system, but I do admit there could be violation of the system. The second one is the C&D waste. Yes, Calcutta Municipal Corporation generates around 500 to 600 metric ton of C&D waste, construction and demolition waste, every day. A construction and demolition waste plant has been set up at Pathorghata, beyond Newtown, Rajarhat area. This is in operation. But unfortunately, the agency is not getting 500 metric ton of C&D waste. Now, when we are talking about the solid waste management system, the main problem that we are facing is parallel economy. What is parallel economy? Parallel economy is that kabadi are there, rat pickers are there. These people are collecting the recyclable materials and these are getting processed through unlicensed agencies. There are. So therefore this C&D waste also we find that private agencies are collecting construction and demolition waste and they are putting for filling up low-lying areas. This is going on. So this particular parallel economy, if we can stop, if we cannot bring it to the main channel, it will be difficult. The other issue that you raised certainly pertinent, but there is a guideline, standard operation procedure is there, set up initially by Central Pollution Control Board. This has been also framed by the state urban authority here, SUDA, and accordingly they are processing the legacy waste with different types of trommels, different sizes have been made, but it is true that certain portion of the remnant of bioremediation of legacy waste need to be again put into the sanitary landfilling. There must be sanitary landfilling as a part of disposal of solid waste finally, and this sanitary landfill will take care of around 8 to 10%, if it is less 5%. So 5 to 10% waste need to be put into sanitary landfilling. It is that every municipality will not have sanitary landfilling henceforth. It has been decided that we will have a sanitary landfilling in a cluster mode so that this small amount of waste can be put into the sanitary landfilling. Sanitary landfilling also need for freshwater processing, waste processing. So this is an important issue that I like to mention, and also I like to mention with respect to waste management, resource recovery. According to our study, if we can segregate at the source 100% of solid waste like organic and inorganic, and this, if it is brought to the processing site, then through processing, first organic waste processing by window composting to compost. Let us take a population of a town, small town, 1 lakh. How much solid waste 1 lakh population generate? 40 metric ton per day. 40 metric ton organic waste plus inorganic waste. How much is organic waste? Roughly 60%. It may be vary. It may vary. But if we consider it is 60%, so 60% of organic waste will produce roughly about, according to our calculation, from 8,760 metric ton of organic waste annually. That means 60% of 40 metric ton, 4 metric ton per day into 365, it is coming 8,760 metric ton of organic waste. This will produce roughly 2,500 metric ton of compost. If we can process that compost properly, and if we can sell that at 3,000 rupees per metric ton, we can get 75 lakhs of that, out of that. But the question is the quality of the compost should be very good, because I have to sell compost to the farmer. It should not have heavy metals. FCO guideline is there, international guideline is there, we have to maintain. So if the organic waste is segregated at my house properly, and if it is collected and put it into processing site, there is no chance of entering any heavy metals or toxic chemical into that. Therefore, this compost will fetch 75 lakhs of rupees. The second important thing is about the inorganic waste, dry waste, which contain very many recyclable materials starting from paper to plastic, paper, cardboard box. We have just seen the composition of the waste that has been depicted here. So the paper, cardboard box, etc. could be sold. We are also selling newspaper at our home at 50 to 20 rupees per kg. Now, plastic has various types. Thermoset plastic, thermoplastic, etc. different type. Now, this cost sale value is varying between 3 rupees to 17 rupees. This plastic recyclable. Now, this recyclable material starting from paper, cardboard box, different types of plastic, then we have cloth, then we have leather, then glass, rubber, etc. Now we consider that 20% of the total solid waste would be recycled. If properly it is segregated and collected. Nobody is salvaging in between generation and the processing site. So out of 40 metric ton generated from 1 lakh population, 8 metric ton can be recycled. Now sale value we consider only 3 rupees per kilogram average. This will fetch 87 lakhs of rupees by selling the recyclables. And then we consider that individual household shopkeeper will contribute 1 rupee per day. That is 30 rupees per month. So 1 lakh population town will have 18,000 household shops, etc. And they will contribute at the rate of 30 rupees per month, and that will fetch 65 lakhs of rupees. So total money we can generate 2 crores 27 lakhs of rupees by this way. Of course, there are ifs, but, constant, etc. Now, if we consider the tipping fee, because you know the tipping fee is there, every country, we are also having tipping fee now. Now, tipping fee with respect to total collection, transportation, primary, secondary, processing could be 1500 rupees per metric ton, maybe 22,000 rupees per metric ton. This is varying from place to place. If I consider 40 metric ton per day generation, and if any agency is collecting from the doorstep through primary transportation, secondary transportation, going to the processing site and full processing, and if we consider 1500 rupees as the fees, tipping fee total, then it will amount to 2 crore 19 lakhs of rupees. So that way, if we consider the circular economy, that is feasible. But what is the problem? Problem still lies with respect to the parallel economy. When they are processing, for example, I had been to Siliguri. Yes, they are getting, we found dry waste, inorganic and organic. Now, when we see the inorganic solid waste, we found 10 to 15% organic matter in there. It is getting mixed. When we found the organic waste, we found many plastic and paper, cardboard box in the organic waste. Because people are now throwing organic waste with a plastic. So therefore, when we are processing, they have to introduce ballastic separator now. Now, unless they introduce ballastic separator, they cannot segregate the organic, inorganic. And when they are segregating, the quality is not up to the mark. Then the sale value of the compost will not be 3,000 rupees per ton. It will be much less. So therefore, feasibility of this system, though we have a rules, regulation, everything, it is very difficult that way we find at the field. So therefore, the awareness, motivation, people's participation is very important. We consider responsibility with respect to urban local bodies, government department only 50%, and 50% is the responsibility of the citizen. If the citizens are not cooperating, it will be difficult. You may raise a question right at this particular moment that, or many people are raising this question, that if we are segregating at the doorstep, we find after that some distance is again mixed up. We do admit, because we have no 100% processing at this particular moment for 128 urban local bodies. Maybe we have 30-40% processing, not more than that. So therefore, if we are segregating 100%, it is difficult that 100% segregate could be processed. So we are now trying here to introduce self-help group. I think Ashraful Islam is also working with small municipality where the self-help group also can do the needful with respect to processing. Some municipalities like Basirhat, I know, where I had been there, the self-help group, mostly women, are involved in the segregation as well as window processing of composting. So they are successful. They are, of course, they are working with respect to say 10 watts or 9 watts out of 25 watts, slowly and slowly. But it is a challenging, we do consider. Definitely we are challenging. And unless behavioral change is not taken place, the solid waste management system per se will not be successful. I think this is, if you have any other suggestion, comments, you can raise with respect to these two papers. তাহলে আমরা ভ্যালিডিটি শুনে নেব। তারপরে ঠিক আছে তো?
এরপরে
দেখবো না ভ্যালিডিটি পরে ডিলেট করে দাও। হ্যাঁ?
There will be a huge rainfall from 6:36 to
অডিয়েন্স কেমন?
আমি রিকোয়েস্ট করব যে ইলেকট্রিক পরে তারপর টিকেট করতে।
So I think it is better. Okay. So thank you very much, both the speakers. Ashraful Islam is a dynamic engineer working in Kolkata Metropolitan Development Authority. I am often meeting with task force, and Akshay is also a very good rising entrepreneur in the state of West Bengal. He has done remarkably well, and you all know, you have seen through social media that he met in a flight with our honorable minister and railway minister, and he gave a chirkut, एक थोड़ा चिरकुट ये दिए थे उनका पास, handwritten small paper where he put his problem relating to transporting the refuse derived fuel to the cement industries. Unfortunately, there is no cement industry which can use the refuse derived fuel in their kiln. It has to go to either Odisha nearest or Chhattisgarh. So, Honorable Minister read his small paper. He was delighted to see this paper and put on to his next senior most officer of railway and instructed the railway officer to contact Akshay and do the needful. He thereafter in contact with the railway officer, and he had several meetings with the railways who promised that they will be helping to transport waste at a lower cost so that we can keep our environment clean. Okay, thank you very much.
So, we are almost closing of the seminar, Sustainable Urban Water and Waste Management through Good Governance. So, participation from the audience, I think around 70 or 75, the corporate members also. Now I request Professor Arunabh Majumdar. Now I request Engineer B.K. Sengupta, former Director General, Kolkata Metropolitan Development Authority, and former Secretary General, Institution of Public Health Engineer, to take the chair. Engineer Kripan Ayudrai, Council Member, Institution of Public Health Engineers, request him to take the dais. And Professor Arunav Majumdar, our Vice President of the Institution of Public Health Engineers, requesting him to take the dais for this valedictory session. Now, on memento will be presented to Engineer Kripan Ayudrai, Council Member of Institution of Public Engineer. Give a clap.
I'll keep it in the IPHE headquarter office. I used to keep it like that. In the rest of the
Now I request Professor Arunav Majumdar to address the audience regarding this seminar.
Respected Engineer Bosishto Sengupta, former Director General KMDA and former Secretary General IPHE, Engineer Kripan Ayudrai, our Secretary, Public Health Engineering, Institution of Public Health Engineering, Institution of Public Health Engineers. We are at the end of two-day seminar on sustainable urban water and waste management through good governance. Speakers, eminent speakers in the three sessions, one on water supply, another wastewater management, and the third session solid waste management, raised very many pertinent issues relating to the services that we provide to the people on water supply, sanitation, and waste management, and requirement of good governance. It is true that we are working hard in this country for providing safe water to the people. We are committed to supply safe water. We are supplying water mostly now, piped water supply system, both for the urban and rural areas. People will be getting water from the tap. But we find people are not having confidence on us. This is sad that people are not having confidence on us because of the fact that people are buying water. Many people are buying water and many people are using water purifier. Now what is it? If I am using water purifier, that means I have less confidence on the tap water. If I am going abroad, say New York or Amsterdam or some other developed country, I can drink water from the tap. I am not buying bottled water, but I can, and I am definitely confidently drinking tap water, but here we find people are having water purifier. I am not contesting with the water purifier. The technology used for the water purifier, excellent. But the issue is that when you are installing water purifier, also we are converting good water to bad water. The water purifier we have studied through our research scholar. extensively. And we found that the treated water are having very less TDS, 10, 9, 20 milligram per liter TDS, pH sometimes less than 6.5. That indicates that good water is becoming bad water and people are having problem. So this is number one. Number two, people are now accustomed to drink RO water. I'm getting many phone calls from my friend whether I will install RO, because a person has come, he is insisting to install RO. Where you are staying? I am staying in Bid Street. I am staying in Rajbari Avenue. My friends said, they are saying we stay in Bidden Street or Rajbari Avenue. Then I said, you are getting Ganga water after treatment. Is there any need to install RO? So this is, we find that the installations are also not perfect. In the villages when we are going, we find people are saying we want to have RO water and they are buying 20 liters jar water. Now this water they are getting from not authorized BIS license holder, because they are buying at 15 rupees per liter, per 20 liter jar. So therefore we find that this water quality is not also favorable. So what I like to mention, therefore, we must grow confidence on the people with respect to our services that we are providing. This is important we do consider with respect to water sector. Another very important issue is with respect to water quality monitoring and surveillance. We have laboratories in the rural areas, but whether these laboratories are delivering good with respect to quality to the people don't know, they don't understand. When we ask school teacher who are coming from different training, whether your water is getting treated, tested, they said we don't know. They don't know about water is getting tested. But there is a system that all rural public water supply system need to be tested twice a year. In urban areas, there is no laboratory that way. Municipalities are not having laboratories except Calcutta Municipal Corporation. So regular water supply system is there and the quality is not getting monitored. We have a very good monitoring system for air quality, AQI, air quality index we know from the newspaper or from signboards. Why not for the water quality? So people are not knowing with respect to the water quality. They are not given the water quality. It is not coming into the public domain, and they are depending on other water supply system, parallel water supply system. Whether we will be happy as a government engineer that the people will be drinking bottled water, so that's why they are safe, or they are drinking water from their water purifier, that's why they are safe. This is a big question. Next, with respect to wastewater management also, we find that the treatment system that we have, sometimes it is not functioning for 24 hours. This is our experience. So therefore, there must be vigil, there must be good governance with respect to the functioning of the treatment plant. We are investing huge amount of money, capital expenditure, but what about operation and maintenance? That also need to be looked into regarding the treatment for 24 hours, because it is a biological treatment system. Regarding wastewater quality monitoring also, there are few laboratories attached to sewage treatment plant, but these laboratories are not functioning well. Nor the authority is looking into whether it is working up to the mark or not. The statutory the authority who is looking after, say KMDA, let me say KMDA. KMDA directly has got no laboratories, no central laboratory. Public Health Engineering Department has got central laboratory or different laboratories, but KMDA, who are maintaining good number of sewage treatment plant in the state, are not having their own laboratory. Yes, they say that we have laboratory attached to sewage treatment plant, but that is run by the contractor. Therefore, you can understand the quality of the analysis. So they are depending on NABL laboratory, and that NABL laboratory are not giving proper report because they are not knowing about the dilution technique, or when they are reporting fecal coliform, they are writing 1600 plus. Whether 1600 plus is 1,60,000 or 16 lakhs, that is not known. So this is very much important about the quality monitoring we do consider. So those things, and lastly, we have discussed very many issues with respect to solid waste management. I have elaborated my comments on this, so I will not again repeat that. With this, I think Chairman sir, Engineer B.K. Sengupta sir will be speaking on pertinent issues, and he has framed a recommendation to be sent to different government agencies after this seminar. So it is now Sengupta sir to deliver your presentation, recommendation.
Friends, we have come to the end of the today's seminar on sustainable water supply and waste management. To be frank, it has become a ritual, so to say, to frame recommendations at the end of a seminar, which is supposed to be sent to specific quarters for initiating necessary action as it is warranted or deemed fit. But it is almost found that the policymakers seldom find time to go through and put a very serious thought on these issues. Though in water supply, there is some sort of silver lining in reaching piped water supply, mainly surface water, in most parts of urban and rural West Bengal, the position with liquid waste management is very dismal. Most of our domestic sewage find their way into the canals and wastewater and water sources. Untreated sewage making the water resources even unfit for bathing in many states. Public apathy and isolation coupled with financial crunch and lesser priority fixation may be some of the reasons. Our sewage treatment plants mostly are in shambles and either do not run, or even they run much below their rated capacity. Our local bodies suffer badly from financial, institutional and financial backups. Also, the developing world solid waste management is a very serious issue. Although various research projects have been taken up for producing manure or generating electricity, it has not yet been possible to scale that on a commercial scale. People's attitude and mindset have not changed to the expected level, particularly for segregation at the point of generation for solid waste, high cost of land, high cost of oil and fuel, rapid urbanization, also all are making dumping and composting a very difficult proposition. All the above points have been discussed and deliberated, but little achievement has been made. After of late, biomining for economization of land, plans for processing public waste, building waste, building rubbish, etc. have been established, but the problem is scarcity of waste reaching to the plant, recycling of waste, both in organized and unorganized sectors, want of house connection in case of domestic sewage, and following of the golden rules of reduce, reuse and recycle in a haphazard manner are rules rather than exception. Large-scale groundwater extraction is probably leading to salinity intrusion in coastal districts, geogenic arsenic contamination, and ground subsidence. It is necessary, therefore, to explore natural resources so that that we do not disturb ecological balance and environmental harmony. Because of a perennial river on one side in our state and wetlands on the other side, we are not feeling the burn. We have all heard about the acute water scarcity in the Silicon Valley of India, the Bangalore city. Let us not invite that situation by our action and deeds. Let us be optimistic and try our level best to make little changes in our lifestyle, attitude, and mindset. Continuous information, education, and communication is what is necessary. We have jotted down certain recommendations, and these are placed below for discussion and acceptance. We hope that these will all be sent to specific quarters for which it is work. Continual harping on the policy makers may one day see some results one day or other. These are the recommendations that I have jotted down. These are not anything new, but almost maybe might appear to be repetition of what we have stated earlier also. Number one, first and foremost is rigorous campaigning through information, education, and communication for bringing changes in the mindset and lifestyle. Human memory is very short. Lived. Number two, water in all its competitive use has some economic value. States must provide water which is for sheer existence. Any water above that need must be charged for to sustain supply with a minimum subsidy. Number three, in flood areas, building rules must be properly enforced to effect house connection such that treatment plants do not languish for want of sewage. Number four, spare the road and spoil the child. Enforcement of regulatory measures requires more careful attention. Number five, haphazard urbanization, filling up of water bodies must be stopped at any cost. Number six, recharge of groundwater, rainwater harvesting, and non-conventional energy sources, particularly solar energy sources, need to be practiced in a larger way. Number six, water quality surveillance have much more scope for further improvement. With medical scientists backup, public health engineers have a very larger role to play. Let IPHE take a leading role. Number eight, every citizen is now having a smartphone, but we have not yet been able to declare many of our rural areas in all ground completely free from open air defecation, free from worm-borne diseases. Number nine, let us all be concerned more about our surroundings. Let us be concerned about global warming, climate change, ozone depletion, etc. But let us be more concerned about our present scenario, local level plantation, our water wastage, and making our environment clean. And then let us our place today to make our planet more livable for our posterity. And number 10, the IPHE must interact with schools and colleges through quiz competition, basic ideas about environment, as they are the best ambassadors for idea dissemination at various levels through their parents and friends. So these are the 10 recommendations that have been jotted down. This is placed before this August House. You must discuss and then take a decision as to whether this will be accepted and sent to various government departments and quarters for acceptance or rejection as is warranted, or they may deem it take. This is now placed before the house, open house for discussion. Yes, please, if you have anything, say anything more to add or direct or anything to any comment to make, then it will be added. Please feel free to say anything you like.
সেনগুপ্ত সাহেব যেটা বললেন, যেটা যদি আপনারা এটা মোটামুটি অ্যাকসেপ্ট করে নেন, তাহলে উনি এটাকে রিভাইজ করে দিলে আমরা আইপিএইচি তরফ থেকে বিভিন্ন দপ্তরে পাঠিয়ে দেবো। ঠিক আছে, থ্যাংক ইউ ভেরি মাচ। আপনি একটু করে দেবেন। ইট ইজ অ্যাকসেপ্টেড, ড্রাফট অ্যাকসেপ্টেড, ফাইনালি করে দিন।
Now I request Engineer Kripanath Rai, Council Member of IPHE India, to address the vote of thanks to today's ceremony.
Good afternoon, dear participants. We are here for the last 2 days, and before I formally offer the vote of thanks, I would like to call upon Mr. Sonkar. Are you there? Yeah. So let me introduce Mr. Sonkar. He is our webmaster, and he is voluntarily covering our program. Not only this, for the last few months, he is covering our program through his own TV channel, .tv, live, and we are able to put it before all the members across the country. And he is also helping us to design our newsletter that we are publishing for the last 6-7 months. And I would like to hand over Mr. Sonkar on behalf of the institution. So that because he will be, at the end of the day, he will be writing our brief report about this, and he will be helping us to publish it in the next journal as well as the newsletter. Thank you. So we had with us the Padma Shri Professor Dr. Ajay Kumar Rai in the inaugural session. The former director from IIEST Shibpur, and we are on behalf of the institution, I am offering my heartfelt thanks for his kind presence out of his busy schedule. I also would like to thank Dr. K. M. Agarwal, Dean of Indian Institute of Social Welfare and Business Management, Kolkata, for his kind presence as guest of honor in the inaugural session, and also Dr. Kallan Rudra, Chairman, Waste Pollution Control Board, as the chief guest of the occasion. So I'd like to thank Dr. Rudra for his kind presence in the inaugural session. We had 3 technical sessions, and I'd like to offer my heartfelt thanks to all the chairmen of all the 3 sessions and all the distinguished speakers who delivered on various issues on water, wastewater, and solid waste aspects before the August gathering. At the same time, I would also like to offer my heartfelt thanks to Mr. Datta Chaudhary, the reporter of all the 3 sessions, who kindly took note on the deliberations and helped our senior engineer, Mr. B.K. Sengupta, to prepare the recommendation, which just now he has submitted before you, and you have kindly accepted. At the same time, I'd also like to thank our former Secretary General, Mr. B.K. Sengupta, being the chief guest in the valedictory session, our Vice President, Professor Dr. Arno Majumdar, for his kind presence and his kind guidance for conducting all this entire seminar. Also, Mr. D.K. Dhar, or another Vice President, who was present in the our inaugural session and delivered the vote of thanks. And overall, I would like to thank our President, Dr. Dinesh Chand, who was present with us yesterday virtually, and also like to thank all the corporate members, those who have joined us virtually from across the country, and those who have watched our program live through the .tv channel. And I would like to extend our heartfelt thanks to all the participants, the students from various universities, our corporate members, delegates from different business houses, those who sponsored our program, and our support staff, our electronic and print media, those who have helped us to bring out the souvenirs and also conduct the program. And at the last, I'd like to extend my thanks to the Stadel authority, those who have supported us to conduct the program. Thank you all. Kindly join us in the tea and snacks and then kindly return to home safely. Thank you.
লাস্ট ছবি হবে যারা আসছেন ফটো তোলা হবে যারা আছেন লাস্ট এসব আসিস ছবি বলছেন যাই ছবি ছবি তুলবে বলছে লাস্টে যারা আছে সবাই ওরা সবাই আছে কপিগুলো কথা একটা গাড়ি বন্ধ করতে না দেখি বন্ধ করতে